Imagine a world where we can create, test, and refine anything in a virtual space before it ever exists in the real world. This is the power of digital twins, virtual representations of physical assets, processes, or systems that are transforming industries across the globe. By bridging the gap between the physical and digital realms, digital twins are unlocking unprecedented levels of efficiency, optimization, and innovation. At their core, digital twins are dynamic, data-powered models that mirror the behavior and performance of their real-world counterparts in near real time. This constant flow of data allows businesses to monitor assets, predict potential issues, and optimize performance with incredible accuracy. From manufacturing and construction to healthcare and urban planning, digital twins are revolutionizing how we design, build, operate, and maintain complex systems. The impact of digital twins is already being felt across industries, and their potential is only beginning to be realized. As we generate ever-increasing volumes of data and develop more sophisticated algorithms, digital twins will become even more powerful tools for understanding, managing, and improving our world. Manufacturing is one of the industries at the forefront of the digital twin revolution. By creating virtual replicas of production lines, factories, and even individual products, manufacturers can gain real-time insights into every aspect of their operations. This allows them to optimize production processes, reduce downtime, improve quality control, and bring new products to market faster. For example, a car manufacturer can use a digital twin of its factory to simulate different production scenarios and identify bottlenecks. By experimenting with different layouts, production schedules, and machine settings in the virtual world, the manufacturer can optimize its real-world operations for maximum efficiency and output. Digital twins also enable predictive maintenance, where sensors on physical assets can detect potential issues before they occur. This allows manufacturers to schedule maintenance proactively, minimizing downtime and costly repairs. By leveraging the power of digital twins, manufacturers can transition from reactive to proactive decision-making, leading to significant cost savings and increased competitiveness. The ability to simulate and analyze different scenarios in a risk-free virtual environment empowers manufacturers to make data-driven decisions that optimize their operations and drive innovation. The construction industry is another sector where digital twins are transforming traditional practices. By creating digital replicas of buildings and infrastructure, construction companies can improve collaboration, streamline workflows, and enhance project outcomes. From the initial design phase to construction and ongoing operations, digital twins provide a holistic view of the entire project lifecycle. Architects and engineers can use digital twins to create detailed 3D models of buildings, simulating different design options and evaluating their structural integrity, energy efficiency, and other key performance indicators. This allows for better design decisions and reduces the likelihood of costly rework during construction. During the construction phase, digital twins can be used to track progress, manage resources, and ensure that the project stays on schedule and within budget. Once a building is complete, its digital twin can be used for facility management, optimizing energy consumption, monitoring building systems, and planning maintenance activities. The use of digital twins in construction not only improves efficiency and reduces costs, but also enhances safety by identifying potential hazards and enabling proactive risk mitigation. Digital twins are also poised to revolutionize the healthcare industry, with the potential to transform patient care, drug discovery, and clinical trials. By creating personalized digital twins of patients, healthcare providers can gain a deeper understanding of individual health conditions and tailor treatment plans accordingly. These digital twins can integrate data from various sources, including electronic health records, wearable sensors, and medical imaging, to create a comprehensive and dynamic picture of a patient's health. This allows doctors to make more informed decisions about diagnosis, treatment, and ongoing care. For example, a digital twin of a patient's heart could be used to simulate the effects of different medications or procedures, allowing doctors to determine the most effective course of treatment. In the field of drug discovery, digital twins can be used to create virtual models of organs or even entire human systems, allowing researchers to test the effectiveness and safety of new drugs in a simulated environment. This can significantly accelerate the drug development process and reduce the reliance on animal testing. The use of digital twins in healthcare has the potential to improve patient outcomes. reduce healthcare costs, and drive innovation in medical research. As urban populations continue to grow, cities around the world are turning to technology to address the challenges of sustainability, traffic congestion, and resource management. Digital twins are emerging as powerful tools for creating smarter, more efficient, and livable urban environments. By creating virtual representations of entire cities, urban planners can model and analyze different scenarios to optimize traffic flow, reduce pollution, and improve public safety. For example, a digital twin of a city's transportation network could be used to simulate the impact of different traffic patterns or road closures, allowing planners to optimize traffic light timing, design more efficient public transportation routes, and reduce congestion. Digital twins can also be used to monitor air quality, identify pollution hotspots, and develop strategies for improving air quality in urban areas. By integrating data from various sources such as traffic cameras, environmental sensors, and social media feeds, digital twins provide city officials with a real-time understanding of what's happening in their cities. This allows them to make more informed decisions about infrastructure investments, resource allocation, and urban planning policies that improve the lives of their citizens. Section 6. Energy powering efficiency and sustainability. The energy sector is undergoing a significant transformation, driven by the need to transition to cleaner and more sustainable energy sources. Digital twins are playing a crucial role in this transition, enabling energy companies to optimize the performance of renewable energy assets, improve grid stability, and reduce their environmental impact. For example, wind farm operators can use digital twins of their turbines to monitor performance data, such as wind speed, blade angle, and energy output. By analyzing this data, operators can identify potential issues before they occur, schedule maintenance proactively, and optimize the performance of their turbines to maximize energy production. Digital twins are also being used to improve the efficiency and reliability of power grids. By creating a virtual model of the entire grid, operators can simulate the impact of different operating scenarios, such as fluctuations in renewable energy generation or unexpected outages. This allows them to proactively manage grid stability, prevent blackouts, and ensure a reliable supply of electricity to consumers. The use of digital twins in the energy sector is essential for accelerating the transition to a more sustainable energy future. Section 7. Transportation and Logistics, Navigating the Future. The transportation and logistics industry is another sector where digital twins are poised to have a transformative impact. By creating virtual representations of vehicles, fleets, and entire transportation networks, companies can optimize routes, improve delivery times, and enhance the efficiency of their operations. For example, logistics companies can use digital twins of their delivery trucks to track their location, monitor fuel consumption, and optimize delivery routes in real time. This allows them to minimize transportation costs, reduce delivery times, and improve customer satisfaction. Digital twins are also being used to optimize the performance of autonomous vehicles. By creating virtual models of roads, intersections, and traffic patterns, developers can train self-driving cars to navigate complex environments safely and efficiently. This technology has the potential to revolutionize transportation, making it safer, more efficient, and more accessible for everyone. The use of digital twins in transportation and logistics is transforming the way goods and people move around the world. Section 8. The Future Landscape. A world enhanced by digital twins. As technology continues to advance, the potential applications of digital twins are only just beginning to be explored. We can expect to see even more innovative and transformative uses of digital twins in the years to come. One promising area of development is the use of artificial intelligence, AI, and machine learning, ML, to enhance the capabilities of digital twins. By integrating AI and ML algorithms, digital twins can become even more intelligent and autonomous, enabling them to learn from data, identify patterns, and make predictions with even greater accuracy. This will unlock new possibilities for optimization, automation, and decision-making across industries. Another exciting trend is the development of interconnected digital twins, where multiple twins can interact with each other to create complex simulations of entire ecosystems. This will allow businesses to model and analyze the interactions between different systems, such as the interplay between a city's transportation network, energy grid, and water supply. The insights gained from these simulations will be invaluable for making informed decisions about infrastructure investments, urban planning, and resource management. Section 9. Embracing the digital twin revolution. The digital twin revolution is well underway, transforming industries and unlocking unprecedented levels of efficiency, optimization, and innovation. As we generate ever-increasing volumes of data and develop more sophisticated algorithms, digital twins will become even more powerful tools for understanding, managing, and improving our world. Businesses that embrace this technology will be well-positioned to gain a competitive advantage, optimize their operations, and drive innovation in their respective industries. From manufacturing and construction to healthcare and urban planning, digital twins are poised to revolutionize the way we live, work, and interact with the world around us. The future is digital, and digital twins are leading the way.